All right, so welcome to class today. I haven't quite been able to get a server up for our class to use for this class period. What I want to do is get a machine we can install ArcGIS server on. Identify the machine, and for those anybody here in the remote sensing class? Yeah. What's that? Yeah, so there's somebody in the remote sensing class. You've probably noticed that Dr. Carter's complaining about getting moving back into the building. We've got all these computers up, but the other rooms where we've traditionally housed servers are still in flux, and they were just here reinstalling the lights, and so I was planning to do this morning, but I couldn't have done it because there was a bunch of construction guys in there doing their thing, getting the drop ceiling back in that room. So we're really close. We've got a server identified. I'm going to use it for remote sensing for the license manager, and I'm also going to use it for this course. Barring totally weird circumstances, we should be ready. That should be ready to go on Thursday. And so today we're going to start talking about, which was the plan anyway, start talking about getting our data ready to publish on a server. So basically creating services that our web maps will be able to consume. And then for today's lab portion of the course, since we still don't have a machine to work with, I think it's a good place to start doing this anyway. And I was planning to do it this week, but anyway, we're gonna introduce the term project, which you all have to do. Graduate students have a little bit more involved project, but everybody has to create a project. So that's what we'll do for the lab portion of the course. So the lab still isn't actually hands-on working with the GIS quite yet, but it will be almost for sure Thursday, if not for sure by next Tuesday. We'll start practicing getting some data and getting that data ready based on what we talk about today. Right? I don't have a slideshow for this week, but I do have the reading up, so I'll kind of do it like I did the first week. And by the way, let's see. Everybody have access to the, where is it? It's down here, web mapping. Yep. Does everybody have access to that yet? Yes. All right. So I'm looking at the course materials, and we'll be looking at designing. Or sorry, that was last week. Week 3, unit 3, reading 1. All right. One of the prerequisites for this course is that you have taken a GIS course, and so we're going to start doing some things that. That rely on that prerequisite. Okay, so we're gonna step through a couple different types of map services over the next few weeks. And we're gonna start with dynamic map services because it's by far the most widely used. If you're talking about just the thematic information that's used on a map, and that is changing over time. People are changes in the. I'm trying to make this smaller. View 1 page. Oh, that's too small. Page width. That's good. That is changing, like I said, as things like the browser speed changes, and like even 5 years ago, browsers weren't capable of doing a lot of things by themselves. They were good at showing images and good at showing text, but now browsers are also good at dynamic changes. They're good at drawing vectors right on the browser screen. And so people are creating more and more services that serve up vector data, and that's symbolized on the map. We pointed that out a little bit. It might have been a little subtle last week, but we did talk about that when we looked at ArcGIS Online and things like that. I'll try to pull up a few other examples today as we go through that, or refer to the previous examples. But today we're going to focus on, I thought that was coming from my computer. Today we'll focus on dynamically drawn map services. So basically, these are the type of map services that are where a server is waiting for a request, and when it gets a request, it returns an image, a map image. And I didn't put all the content up here for this week. We'll finish this off on Tuesday, but we'll start out doing this. So just to review, this is in contrast to the other two ways. If this was a PowerPoint slide, these would be bullet points right here. This would be a bullet point. One way is for the server to send pre-drawn map images. We often call those tiles. That's like what Google Maps does. Another way is for the server to send a bunch of text and attributes that the browser draws. So it could send a bunch of latitude and longitude points, and the browser puts points in those locations. Or it could even send a bunch of line coordinates, and it puts those line coordinates into the browser. And then the third way is to draw a map on the server at the time of the request is sent to the browser, and then send that map back. But it's drawing it right when the request comes in. In other words, there's a program waiting for that to happen. So, in practice, many web applications, as we've seen, as you've gone through the first assignments for this course, actually use a combination of these. Almost all web maps today use a tiled-based map, and then either at least one of the other two. Either they get data that they draw then on the browser, on the map itself, or they return a map image that's placed on the very front of the map. That's placed above the tiled base layer. So sometimes we call that a dynamic map service. Sometimes we call it an on-the-fly map service. And one of the big advantages is that it reflects the most recent picture of the data, so things can change. If your data is changing over time, this is often a good choice. And then I did note here that there is a hybrid option where the tiles are drawn dynamically, but then stored in a cache for subsequent use. Did anybody notice yet one of the websites we've gone over doing this? We did mention it last week. Anybody think of what I'm talking about or referring to? It's okay. I know it's still early in the semester, but that's basically what CartoDB was doing. If you looked when you panned or zoomed after you uploaded your own data, the tiles would come in as tiles rather than a single map. And so CartoDB is doing that sort of thing. It's using a hybrid approach where it's drawing tiles dynamically. And the reason that it does that is that if you went to a web page and you went to a map service and you moved that map service just slightly, like let's say you're like, oh, I just want a slightly different view of this layer, and you panned over to the left or you panned over to the right. If you have a purely dynamic map service, your browser then will request a brand new image, an entirely brand new image, even though you only panned to the left or right a slight bit. Okay, and so it moves over. You move over, you get a brand new image, and it replaces the thematic base layers with that brand new image. So there's some latency involved, and it's drawing a whole brand new area. However, if you were to do that using this hybrid approach, a tiled a dynamic tiled service. Those tiles, actually, depending on how far you pan, if you pan so that some of those tiles were still just sitting barely off the screen, it may not even make a request back to the server. However, if you did need some new tiles because you panned over far enough, it would request only those tiles that you needed in order to draw the map. An example of a web page that does that is one of my graduate students created. Hopefully it's up right now. Mappossum.org. Okay, so this one, it allows people to answer questions. I'm trying to find a more interesting one. Okay, so at least at least that one has some more answers, but it's not super interesting. But if I zoom in and out, you might have been able to see as I went from question to question, see how it's pulling those data in as tiles. See the tiles popping in. But now when I pan back to an area I've already been to, no request is made to the server to get those tiles again. So those tiles are being drawn dynamically on the server because this data does change. Now, if I went in here and answered a question and said, well, I'm over here in the Western United States, and I answered this question. Now I zoom back out, and the answer to my question was added. I said that I was somewhere in California is where I put that hash mark. So it added California to this thing. I've skewed James's data here by answering the question, but it draws that dynamically, but still does it as tiles. So it's becoming more and more popular to do that. ArcGIS server, which we may install it as a group in class, or I may just install it. It only takes a few minutes to install, and it might be interesting to see. So if you have an opinion on that, just let me know. But we'll look at that next week. ArcGIS server does have the ability to do this hybrid option, basically to create tiles on the fly, and really the advantages to doing that are mostly found on the client, because the server has to do just as much work. In fact, maybe just a little bit more, okay? Because it might be harder. I don't know this, I haven't tested it, but it might be slightly more work for the server to make 8 tiles than it is for one single image. However, once all those tiles have been made, they don't need to be updated again until the data changes, and that's what's nice about the technique. All right, so a little bit of a blurred line between these two concepts of it dynamically. We're going to focus on dynamic maps today, and almost everything else I say today about dynamic maps will apply equally to tiled maps that are created dynamically, as it will to just a traditionally dynamic map. The only difference is that you get that benefit on the front end of not having to request not having to make another request to the server as often. Okay, so these are the advantages of a dynamically drawn map service. Obviously, I've already mentioned that because your data might change, this is an advantage. I thought I just told it not to. If your data changes, it's definitely the one to try. Now, another advantage is that tiled maps that are stored as a cache on your server can never even change symbology. In fact, if you have a single map tile, you can't even change the drawing order in the map tile, because that map tile is a picture. Okay, it's just a single static picture. If you remember when we went and looked at those tiles, when we went to the developer source and we brought the tile up itself, it was a PNG. It was a picture. Okay, we can't take the roads and lower them back under a vegetation layer or something if we wanted to. Though they're already burned in as a single image. There's no changing them. They've already been created in most cases. Okay, so that's the advantage of a dynamically drawn map service, is you can often change the drawing order of the layers, and in some cases you can change the symbology. Now, in both of those things that I just mentioned, it's not true of every dynamically drawn map service, but you have to have a dynamically drawn map service for those to be true. So no cached map services or no cache map layers ever allow you to change the symbology or the laying order. Some dynamically drawn map services allow you to change the drawing order or the symbology. Okay, and there's two different you know, we're going to make this distinction between free and open source software and ArcGIS for the most part, being the commercial software that we'll use. And actually, when we talk about now that we're starting to get into using software, we're going to utilize GeoServer as our free and open source version. There are other versions, and we're going to use ArcGIS as our example of a commercial. Okay, but a lot of these concepts carry through to both, but actually the way you implement them is different. And so the way you implement changing the layer order or the layer symbology in GeoServer, and in fact in many FOSS alternatives, is through what's called a style layer descriptor. And a style layer descriptor is it's kind of like HTML. It's a markup language that you use to create your maps. Now, sometimes it's hard to create markup languages when we're not familiar. Like, who here could just sit down and type up an HTML document? You probably could clunk your way through it by surfing the internet and finding out what tags mean what. It's the same with a styled layer descriptor. Oftentimes, you could clunk your way through it, but there are tools. There are tools in ArcGIS and there are tools in QGIS that allow you to export a styled layer descriptor that will allow your end users to play around with the styles of your map document. And we'll get into to doing that in the coming days, probably on Thursday. Now, ArcGIS server doesn't use styled layer descriptors, but they still have this functionality where you can modify the layer drawing order, or you can modify the symbology by sending information along with your request. Okay, so we'll go through each of those. They both have their advantages and disadvantages, and they are different. But in both cases, the server has to be you have to make your map service able to accept these kinds of things. You could say, I'm publishing a dynamic map service, but I'm not going to allow. That's kind of the default. I'm not going to allow them to make changes. They get what they get. They can turn individual layers on and off, but they can't change. So the default is you can turn individual layers in this map service on and off, but you can't change the symbology or the drawing order. That's the default. But you can make those changes in both the free and open source world and the ArcGIS world, and that's a big advantage of dynamically drawn map services. So let's see. Oops. Slash Gulf of Mexico. Here's an example of an ArcGIS server handling some dynamic changes. So there's this thing that we've developed called the Restoration Explorer. Might as well choose Mississippi. We're in Mississippi. So here we are in Mississippi. This is a map service that's being shown on the right here. This is a map service, and these are basically big polygons. And this is the default. This is the way it was published to look. So if I went there, I published it to look like that. When I want to do things like this, I can change the sliders, and the sliders then make a new request for a new map symbolized differently. It was probably hard to tell, but the map did update. It changed. As I change these slider values, I'm asking it to make a change in the service. The reason I'm showing you some of these things is because this will help kind of formulate ideas for you as you think of things that you can do for your final project. But see how when I move the sliders, it changed what was on the map. And the way that's doing that is the slider is making a new request, telling it to change the symbology and apply a different type of symbology to the map. I could use it to change a categorical symbol. Like I could say, okay, I want to see everything that is that's good one color and bad another color, or something like that. All right, and then let's close that for a second. Here's like here we've created a just like a layer list, a typical layer list. So if I turn this oyster restoration sites on, it shows that oyster restoration site. It looks like there's not a whole lot of them, and that particular map service, there is not any way to. Oh, there's a couple more over there. There's not any way to change it. We've published that one and created that map service to not be able to change the display. Okay? There's nothing interactive to do. It's just showing those layers on a map. If I went to view in the developer tools, the JavaScript console, see if I can inspect that element. It doesn't show that. Console. Network, that's what I'll do. Choose one. All right, so here's my here's these dots coming through. They're just coming through as images. All right. Okay. So where was I? Back over here. So what are some disadvantages to dynamically map service? Well, I've gone over these. Okay, it's basically it can be slow, particularly if your data set is complicated. Last week I mentioned if your map draws slow in whatever desktop GIS software you're using, it's going to draw slow on the server. And many of your users of a web map are different than the users for a GIS system. Okay, your web map users are often a wide audience of people that are not as familiar with GIS software, right? I mean, that's the whole reason why you create a web map, is you want lots of people to use it, and they may not be experts in geographic information systems. Okay? So these people are used to web maps performing quickly, like Google Maps, and so if your dynamically drawn web service takes a long time to appear, people may they may give up. Okay? So dynamically drawn web services are also more susceptible to overload. What do we mean by that? Well, tiled map service is just giving images out to people, so it scales really well because it's just continuing to give images out to people. Dynamically drawn map service is running a program every time a request is made. So if 5 people are using it, it may be okay, but if 100 people all of a sudden are using your map service, it may cause the computer to have an issue, because it's basically running. Early map programs were basically firing up ArcGIS, or firing up the GIS software, drawing it, and then sending it out. Luckily today they're not actually opening it every single time, but still they aren't as scalable as a map cache. So yeah, so Here's some software for dynamically creating dynamically drawn map services. We're gonna refer to them as map services. Okay. So in this course, we're going to use ArcGIS server and GeoServer. I already mentioned that, but there are other free and open source software options out there. There's map server. There's QGIS server. QGIS server basically allows you to take things that map documents you make in QGIS. Has anybody made a map document in QGIS before? Not a whole lot. You have? Okay. We'll probably do that in this course. Well, next, what I want to do is make a dynamic map service. You guys make a dynamic map service. When we'll make one in ArcGIS and we'll make one in GeoServer, or maybe even QGIS server. I was thinking GeoServer, but we'll make one of those in each, and we'll publish them, and you can see some of the differences. Okay. QGIS server is currently not available for Windows. Well, maybe that is true. So that would preclude, because we're going to be using Windows machine. All right, now others. It says others. Really, WMS is an open specification, so anybody and their dog, if they know how to program, can create their own WMS, and there are a lot of options. I've listed those in some of the other readings. So some people have created very focused map services that just do a few things. So they don't have all the bells and whistles. GeoServer is a competitor ArcGIS server. It's trying to directly compete with us. It's providing you all sorts of different ways to symbolize your data and show your data. But some people out there are like, hey, I just want to get this map up on the web, so they're not very user friendly. They require lots of configuration files. They often don't have a GUI interface, and they are useful for people though that just want to get a particular map service up. They don't want to support all the other things that GeoServer does, or they don't care about all the other stuff GeoServer does. Now, I think I left out a paragraph that I was thinking of putting in there, but there's basically two different services that are available, two different types of services that can be created for map services. And there's one that's an open standard, that's called WMS, stands for Web Map Server. I think we've gone over that enough already though. And then the other one is the ArcGIS server, ArcGIS server. And ArcGIS server creates it a little bit different. And we'll talk about those as we create them. So next time we meet, we'll go into further details about that. All right. Now, before we get into the lab assignment, and we still have 20 minutes or so, so this will be good. Before we go into the lab assignment, I want to go over some of the things that you need to think about when you're creating your own map service. So when you're going to take your data and turn it into a map service, and all a map service is a computer program running, waiting to create maps for your web map. Okay, a map service is not the same thing as a web map. Your web map consumes map services. So when you're going to create your map service, what are some considerations? Well, rather than type all these up, I'm using a guide that's created by ESRI. Now, some of these are ESRI specific, and I'll point that out as we go through them. But some of them are universal. They're just good concepts. You want to do these sorts of things. Okay. So this is a guide that you should consider when you're creating a web map. So when you're creating, they're calling it authoring. When you're authoring a web map or a web service, sorry, that will be used in a web map, these are some of the things that you should do. Okay. So here's some general tips. You know, obviously, special characters. If you can avoid using special characters in your data, then do so, because they often take extra time, and sometimes they'll even mess up a request because the data is not encoded correctly. It's not so much of a big deal. All right, let's skip down. So this is something that's ESRI specific. So we'll come back to that when we cover that. Okay. Okay. One thing that's, when you're creating a dynamic map service, one of the first things that you should consider is, can you get away with doing a cached map service? If you can get away with creating a cached map service, switch to that. We'll talk about that more next week, but we'll talk about more how to do that next week. But think about, does my data change that much or at all? And can I put this layer as a cache map? A cache map doesn't have to be, it can contain invisible areas. Okay. PNGs and GIFs both allow transparency. So you can have an you can still make, in fact, MapAwesome, the thing I showed you before, I already closed it, but the tiles that it's using are contiguous. In other words, if something shows up here like this, there's still a tile that goes like this, but that tile, the rest of that tile is transparent. More tools, JavaScript console. Yeah. You probably get what I'm saying there. The rest of this tile that's created here is transparent. Let's pull that up. See, the gray boxes are in fact, the particular tile I'm showing right there is totally transparent. The gray hash pattern there indicates a transparent area. If I clicked one of these guys, it would show me, one of these would show me the parts of the state of Mississippi. But I'll spend a bunch of time clicking on that. All right, so a cached map doesn't have to be wall to wall. It can contain thematic elements if those thematic elements don't change. All right. But for uncached maps, okay, performance tips for uncached maps. These are some things that you should consider when you're creating or authoring your map services. First, the thing on there says set a scale dependent rendering for data layers. What does that mean? Anybody know what that means? What I'm talking about there? Let's say you have a roads layer, okay, and that for some reason that roads layer changes a lot, so you're creating it as a dynamic layer. Okay. Now remember, a map service can contain multiple layers. So when I say a roads layer, I mean a layer that has roads in the United States. Okay. Would you want every road to show up if somebody was looking at the entire United States? Think about how long that would take to draw. It would take a long time to draw, right? And so you would probably just want the interstates, maybe not even all the interstates, but at least most of the interstates to show up if they were looking at the entire United States. And then as that layer, as that user zooms in, you would want to see more and more detail. Okay, you can do that in ArcGIS. You can set it up so that as you zoom in, other layers turn on. So typically, if you have scale dependency set, the layer shows up as checked, but it's grayed out. When you make a map service, whether you do it in the free and open source world or in the ArcGIS world, you want to set the same kind of scale dependencies. Those are important because oftentimes very detailed layers will draw quickly if they're only drawing for a certain portion of the world. So in other words, if you zoom way in, your roads will show up. But if you zoom out, you'll get less roads. That's a good tip or trick, is to make it so that your layers will only draw if the user is requesting a map that's a certain scale. Does that make sense? And that will cause them to draw more quickly. All right, remove unused layers and data frames. Obviously, if you're publishing a map service, don't put additional data in that map service that nobody's going to use. That's pretty straightforward. That's what that's saying. Okay, if you have in the ArcGIS world also, if you have additional data frames in your map document, get rid of those for publishing. So you often have separate data and separate map documents for publishing than you would for just handling the data otherwise. All right. Anybody know what a definition query is? All right. What's a definition query? Describe it.
Querying your data to show, basically almost like a SQL query.
Yeah, it is. I mean, lots of times it is a SQL query.
You're just querying data to show, specific attributes in the.
Right. So if I had a counties layer of all the whole United States, and I wanted to make a map service that would just show the counties in Mississippi, one alternative would be to put a query in that would say if state name equals Mississippi, show it up. The problem is, and that's not horrible, and sometimes it works acceptable. But if you want to speed your map up, don't put that query in there. If you're trying to make it run faster, this is one way to do it. It may or may not increase it a whole lot, but instead do that query beforehand and extract just the Mississippi counties if that's all you really care about, and create a new layer that contains just the Mississippi counties. Because if you don't do that, every time you pan or zoom, that query is reapplied when that new dynamic map is created. And so it's thinking about that query and running that query code every time you pan and zoom your data. And so that's one way to increase the speed. Now, if you actually have an application, well, let's say you have a drop-down that says, show me the counties in Mississippi, and then it shows you the counties in Mississippi, and then you choose Alabama, and it shows you the counties in Alabama. Let's say that's one of the functions that your web map wants to do. It's dynamically show different different counties in different states. Then go ahead and leave it in, and you take the performance hit because you wanted it to be dynamic. Okay? It would be your server will also take a performance hit the more map services you have. So another way to do that would be to say, okay, well, I've got a map service for Mississippi counties, a map service for Alabama counties, a map service for all 50 counties. Well, your computer is running a program for every map service, and so it's running that program in the background. It's going to take a hit running all those programs. Okay, so there is a trade-off. There is a time. What I'm trying to say is there are times when query definitions are appropriate. That's why it says use definition queries appropriate. Sometimes you can't get around it. Sometimes you can. Usually, if you have it embedded in your map document, it's not appropriate because you're just forcing that all users to use that thing. There's no way to change it. If it's something that the user is doing and you're modifying the map service through the request, that's usually an appropriate time because what you're adding is functionality. Okay? But if you're making a query definition on the server side that nobody can change, make the new data that has it. Otherwise, you're filtering every time somebody makes a request. All right. Now, of course, you want to have your maps look great, but simple is better a lot of times in cartography, and particularly on the internet. Remember that most people are looking at these through computer screens, and so computer screens have far less pixels available than a printed map. And so simplify your symbols. Complex symbols take longer to draw than simple symbols. Sometimes you can't get around it. The example here are highway shield symbols. Sometimes that's what people expect to see as a highway shield. However, there are different formats depending on. This is probably ESRI specific. An EMF file is better than a bitmap. That's probably ESRI specific. But look at whatever software you're using, and maybe there's other recommendations as to which symbols draw faster than others. Okay. All right. Here's a big one. Use annotation instead of labels. Okay. The difference between annotation and labels are that annotations are things that are drawn on the maps, and labels are things that are dynamically created every time somebody moves around, and they're actually associated with the feature. So it's often a good idea after you make a map document, if you're using ESRI technology, to take your data and convert it to take your labels and convert it into annotation. And that way the code that symbolizes or that redraws the labels won't run every time through, because it's not rechecking, well, what's the name of this feature, because the word, whether it's New York or Indiana or whatever, that's just there. That word is already saved in the map. I'm saying that label. Okay. ESRI calls it a label when what it's doing is it's saying, oh, okay, what's the name of that road? Oh, it says it's New York. I'm gonna write New York here. That process that it goes through takes a little while. All right, simplify your labels. Remember things like halos, offsets, following a river boundary. Those things take more time. Those things really should be pushed into cache map services anyway. Those are base map items. Okay? Rivers don't change course that often. So if you have a river in a dynamic map service, you could probably push it into a cached map service so that it would speed up performance. Because then once it's created, it's there. It doesn't have to redraw it every time. All right. You can also, in addition to setting scale dependent rendering for your features, you can do it for your labels as well. Okay, this is a big one. This is one that I see a lot of people forget, and it does have an impact on your map service. I don't know what the number is, but 90% of the map, I don't know exactly what the number is, but 90% of the web maps in the world today use the same map projection because there's so many available base maps. And that's sometimes referred to as web Mercator. The code for it is the current code is 3857. If you plan to use your dynamic map service, your dynamically drawn data, with a base map that's provided by Google or anybody else, it's always best to pre-project your data into that projection. Because if you don't do that, every time you pan or zoom in, zoom in, zoom out, every time a new request is made to draw a new map, it's projecting that information on the fly, and so it'll draw faster if you do those computations ahead of time. And that's true regardless of whether you're using a Google style base map. When I say Google's the first one that created this base map, but this isn't a Google base map, but it's still the same projection. Web Mercator is what we come to call it. Okay. Most web maps today use it. But even if you're not using that, always remember to use whatever coordinate system you've chosen for the map. So all your map services should be using the same coordinate system, and all your data should be projected into that same coordinate system. There shouldn't be any projection on the fly happening. Okay. Can somebody explain projection on the fly? What do I mean by that? You guys should know that when you bring up multiple layers in a GIS, just because they overlap does not mean they're in the same projection. Everybody knows that. Some of your data could be in different projections, but it's being projected on the fly, being merged, shown as the same coordinate system on the map. Okay. So if you bring up ArcGIS, you can right-click properties. There's a way to do it in QGIS too. Right-click properties, find out what projection it is, and make sure each of the data sets is in the same projection. And most of the time, that'll be Web Mercator 3857. Okay. All right. Okay, now this is something that you would do once your map service is created. And there's a few other things that you do once your map service is created. We're going to get into that a little bit more when we actually create map services. So I'll leave that one to be explained later as the rest of this document. Now we're going to use something like this document when we actually go to publish our map services. So you're welcome to go through this and see some other information and read about it and learn about it. But that's what we're going to do, and I'll come up with a similar guide for GeoServer if that's what we end up using, which I'm pretty sure it will be. Okay, so that concludes what I wanted to talk about today. For the lab portion, we could take a 10-minute break, but since we're not going to do a formal lab, since we're not going to actually use the computers, let's just go through this, and then you all are free to leave if you want to. Okay, so I want to get a good start on this term project. I don't want you guys to get towards the end of the semester and still be thinking about what you're going to do for your term project and where you're going to get the data. Let's go ahead and start tackling this, and that's why I came up with this assignment. So in this course, we're gonna walk through a lot of the different processes that you'll need to learn about to create GIS services and to create web maps. Okay? That's the ultimate goal, is to create a web map. So you're gonna do these weekly assignments. You may not actually know how to do everything that you're going to use in your web map until later in the course. Okay? That's to be expected. All right, but eventually you're going to create a web map for this course. That's one of the final goals, and it's going to have some degree of interactivity. It's basically got to include something with either pop-ups, filters, queries, something like that. Okay. There's a bigger description of exactly what it has to include. Go back and read the syllabus. But that's what it is. So we're gonna have a couple of lab periods where we're just working on the final project. But like I said, I want to get this in place so that you have an idea of what you want to work on. Now, the assignment here, if you read it, is basically coming up with what you want to do for your final project. Now, I realize that there's still plenty of time, even though it'll go by quickly, there's still plenty of time in this semester to work on a project. And if your project changes, that's okay. Come talk to me about it, or resend this email. But what I want you to do is start to look through the syllabus, look through the lecture titles. You can even talk to me and say, okay, hey, are we going to cover this kind of functionality? Am I going to be able to do this? Basically, you're going to come up with an idea for your web map. Okay, this will help you choose a project that's within scope. I'm not expecting you to recreate some awesome web map for this class. Okay, the scope of this project is a simple web map that has some functionality to it. It has to be dynamic in some way. It can't just be, by dynamic, I don't mean it has to have a dynamic service, but it has to change based on some user input. You got to be able to turn off and on some layers. You got to be able to. That's one example. You may or may not have to be able to turn off on some layers, but something has to change in response to the user clicking something, making some changes on the map. Okay, and I want it to be something that at least somebody could think of as useful. It can't just be, hey, I got all these layers, I'm gonna turn them on and off. Isn't that great? So it has to be cohesive. All right. So do some investigation, whether that involves talking to me or reading the syllabus or looking at the syllabus, looking at the things that we're going to cover. But you've got to come up with a project that's in scope. This will also get me an idea of what you guys expect out of the class. This is not an assignment I'm going to grade hard. This is an assignment I'm going to say, Did they complete the assignment? You get it back, that'll be great. So read the term project submission guidelines. Create a 1 to 2 paragraph write-up, okay? Double-spaced, describing an idea for your term project. Okay, you should mention the base maps that you're going to use. It's okay to use pre-existing base maps. You should use, you can talk about thematic layers that you're going to use. You don't have to mention exactly what technology you're going to use. You don't have to say, oh, I'm going to use ArcGIS or I'm going to use free and open source software. Okay, but decide what base maps you're going to use, what thematic elements, and what your interactive elements are going to be. What's it going to do? Okay, that you'd like to have in your project. One thing that I do want you to do is have an idea of where you're going to get the data. Okay? You know, I'm willing to point you to some places where you can get data. You can get data at Maris. Okay? You can get data from various federal government websites. But try to investigate where you get the data. If you come up with an idea and you want to email me beforehand and say, hey, do you know where I could get some data for this? Let me know. Okay. All right, I got some bad English right there. Email me your this. Email this to me at the class email address rather than posting it on the forum. So this is the first assignment. We're going to have a fair bit of assignments that are email. This is the first one. You're not going to post this on the forum. You're going to email this to me. So you're going to submit this portion a week from today. I don't care if it's like at midnight. Some people email me and say, well, what time did you mean? I'm not really a stickler on the time. Just email it to me next week. In fact, if you're a day late, you know, we're all good. Okay. What I really care about is that you then have time to do the second step here. Okay. So the second step here is that you're going to start preparing your term project data. And I'm going to give you a few more weeks to do this. So you're going to get your data in hand so that you can actually start making web services with it, so that when we start doing the other exercises in this course, you can use the data that you're planning to use. You can use the sample data I put up, but you can also experiment with that data. Okay? So feel free to collect the data you want to use for your, when you're thinking about this, feel free to collect the data. So in other words, you can do this over the next week if you want to, but definitely after you get approval, go get the data, okay? So I'm going to email back approval of the project, then you're going to go get the data. I wrote this like in future tense. So if you've already, what I'm trying to say is if you've already identified the data while you're doing the write-up, that's fine. But if you haven't, identify some data of interest, either from your workplace if you have a job. It doesn't have to be a GIS job. There's lots of spatial data out there, or data that can be turned into spatial data. Okay. You know, if you had, I'm talking about graduate students here. You know, if this is something that you want to, that utilizes data that you have access to as part of your graduate work, that's fine to do too. Okay. In fact, if it was something that actually that you could work on as part of your job/graduate work, that's fine as well. Okay. The data has to include base map layers and thematic layers. Your base map layers could be as simple as saying, I'm using the Google base map, so I'm good. You don't have to actually acquire the data. They're not going to let you have it anyway, but you don't have to acquire that anyway. But if you are going to use a custom base map, get that, get the thematic layers, and like I said, if necessary, you can create some of the layers yourself. There's ways to get data that's latitude, longitude into ArcGIS or into QGIS. From there, you can get it onto the web. There's ways to take imagery and georeference it. So a lot of you should already have those skills. If you don't, or if you have questions about exactly how to do that, let me know. Okay. All right. So when you get these data, most of the time, I doubt, especially for your thematic layer, that they're going to be in the map projection that we want them to be in. So one thing I want you to do is convert them into Web Mercator. You can do this in ArcGIS. You can do it in QGIS. The code there is 3857. In ArcGIS, it's under Projected Coordinate Systems World, I think. And then you got to scroll down to Web Mercator. Now, be really careful because there's one called World Mercator. Okay, and that's not the same thing. Web Mercator is the one you want. Web Mercator has had a few different codes in the past. Okay, 900973 or something is one of them. And then 1002. Anyway, they've had a few different codes. So if it says Web Mercator or Web Mercator Auxiliary Sphere, technically the one that says Web Mercator Auxiliary Sphere is 3857. That's the one you want. Okay, Web Mercator Auxiliary Sphere. If you have questions, email me or come talk to me. Right. So it's going to make what I was trying to say there. I didn't say that very well. What I'm trying to say there is we're gonna do this as part of an assignment, as actually convert this data. So if you want to wait until we'll either do it Tuesday or Thursday or next Tuesday, we'll create some data. If you want to see that done in ArcGIS, I can do that. That's what I meant by that. All right. Then you're gonna write a little write-up about your choice of data sets, how you got them, how you processed them, and indicate which of the data sets will act as the thematic layer in your eventual web map. And I want you to include some screenshots of the data. Okay, but you know how to make a screenshot? I think you can just press print screen. There's also the snipping tool, so you can cut and paste it into a Word document. I just want to see that you have the data. Don't worry too much about cartography at this point. Make sure that you have it, put it into a Word document, and send it to me. Okay. Now you got quite a little while to complete this. You have till September 17th. If you need more time, let me know. Remember that we are not meeting on the week following. I think it's actually going to end up being September 17th. What day is that? Thursday. Okay. So originally, I thought it was going to be this day, the 22nd and 24th, that I was going to be gone. It's looking more and more like it'll be the 17th and the 22nd. The tickets. I'm doing some field work in the Caribbean, and the tickets haven't been bought yet, but it's looking more and more like it will be that I'll be gone from the 17th to the 23rd. So anyway, there'll be 2 class periods that we'll miss. But this is due the 17th. But if you need a few days, I'll be traveling anyway. So let me know, and we can be flexible on that. But yeah, I would like to get that done before the first. Before first part of the course. So that'll be somewhere in this time period. We'll talk about. We'll get this done. Anybody have any questions on that? Does that sound doable? Sound fun? Maybe not. But, making a web map. Who all is down there today? I can't see anybody still. You're hiding in the corner.
There's 2 of us.
Okay. Okay.
Yes.
Is Jonathan and Michael?
Yes.
Yeah. All right. I guess I can see one of your heads. Sorry, I blended in with the monitor. But one of you is off the screen. There you are. I can see your shoulder. It doesn't matter. I'm just curious as to whether I'm talking in an empty room or not. But it's good. It's good to have you all. And if you have questions, let me know. So today that's the lab assignment, to start working on that, okay, rather than having a computer lab assignment. And once the Walker Science Building gets back in the swing of things, we'll have our computer up, and hopefully that'll be on Thursday, and we'll cover publishing these map services. All right, put some of this stuff into play. Anybody else have questions? You're free to go then. I'll be around. I'll just I think I'm going to head over to my office rather than just stand around here. But if you have questions, do that. Let me know, either by email or stop by. And we'll leave it at that. It looks like the Hangout didn't